So now we are going to follow up on our discussion for talking about the 12 chord rules, rather the 13 rules in fact, and we have already done the first 6 rules, which is from 0 to 5, right? So if you have not watched that video, I would recommend to go and watch that video first and then come over here and take a look at this one. Okay, so we'll start our discussion with rule number 6 now, when we have already covered the rules from 0 to 5. So the rule number 6 says, and it is known as the view updation rule, which means that all the views that are theoretically updatable should be updatable by the system as well. Okay, so views are nothing but different like views only, in fact, like scenarios that you consider, or certain columns that you pick up, certain like rows that you pick up, and try to create a view based on what query you have, right? You try to generate views for your databases. So any views which look theoretically that it can be updatable, right, it can be made changes for, it should actually be updatable by the system as well. That means if I actually practically write a query to update that particular system, or try to update that particular part, or like a certain data, it should actually be updatable by system as well if it is theoretically possible to update the data. Now rule number 7 says relational level operation. So it says that there must be insert, delete, update operations at each level of operation relations. Okay, relation is nothing but a table is. Okay, set operations like union, intersection and minus should also be supported. Okay, so it says that no matter what table you are dealing with, okay, no matter what level of the table is, maybe it's a accumulation of 2-3 tables, or maybe it's like the lowest level, at the basic level of the table. So no matter what the table is, the operations, basic operations which we are trying to devise for DBMS, right, should be possible to do at each and every level. So if I want to do insert operation, delete operation, update operation, all of these operations should be possible to do on the tables. Okay, and certain set operations also, like let's say you have a set of tables or set of data from a table in one part and some set of rows in another part. If I want to perform union, if I want to perform intersection, if I want to minus, right, I want to take disjoint, all of those should also be supported. No relational DBMS system is actually complete without having the support of all of these operations. So if you're not providing support for all of these operations, that is a direct violation of rule number 7. Now we come to rule number 8. Rule number 8 talks about physical data independence, which means that the physical storage of data should not matter to the system. Okay, if say, let's say some file supporting table is renamed or moved from one disk to another, it should not actually affect the application. Okay, let's say you in your database is storing a lot of information. Okay, let's say in a file you are storing some it's supporting a table, and now somehow you renamed the file, or you moved the file from, let's say, one disk to the another disk. As a user or as an application, or the UI or the interface for RDBMS, it should not affect anything, right? Internally, how the data is physically stored in the disk, right? How is it the way and the structure that is used to store all of that data in RDBMS in disk structure should not affect the way the application is actually working, right? And it should not affect the entire RDBMS system. Okay, so both of them should be independent of each other. That is why it says physical data independence. Physical is like reality, like physically you have hardware, right? So hardware and disk, whatever is being used, right, to actually store the data, that part, and the way you actually look at the application, right, you look at your data in using the RDBMS, that should be completely independent, and they should not get affected by the change in one. Okay, next says is rule number 9. Rule number 9 simply says or talks about logical data independence. So it basically means that if there is a change in the logical structure, okay, let's say somehow you were using 5 columns in a table, but now you change it to, let's say, 3 columns in a table. Okay, if there is any logical change in the structure of the database, the user of the data should not change. It's not like the moment you change the structure of the data, the user is also looking at the data in a different way. No, let's say if a table is split into two tables, okay, a new view should actually give result as the join of the two tables. Okay, so it this point actually came up, I think, in some other section as well, where we do not want to lose any data. Okay, there's a concept of data preservance. If we have some data, we do not want to lose any information. So let's say if I have a table and I split it into two tables, okay, so the new two tables that we actually have, if I try to join those two tables and create a view out of it, right, that should actually give me the original table itself. Okay, and that is what it says in this point as well. Say if there is a table that is split into two tables, okay, and a new view can be created, or if I generate a new view, that should actually give the result that is nothing but a join of the two tables. So internally it may happen, right, that a table is split into two tables, let's say for storing purposes or any purpose. I like the reasoning for that could be anything, right? But let's say internally what happens is the table that you have, right, it got split into two tables. Okay, now the new view that will be generated, okay, it's not like the user will also start looking at two different tables. The user will look at the single table itself, okay, which is nothing but the join of those two different tables. Okay, so it's not like if I will try to look at that table, I will also start seeing the splitted tables. No, internally they can be stored at two different tables, but as a user what I will see is nothing but a join, okay, of the two tables over here when I look at it. So as a user, my user view of the data never changes. Okay, even if there is a logical change in the structure of the table of the database. Okay, and it says in the end that this is actually one of the most difficult rules to satisfy. Okay, out of all the rules that we have, this one is actually the most difficult to satisfy. Okay, and that's what it talks about in the rules for logical data independence. Okay, so there are two rules. Physically means if the hardware changes, if the hardware does some changes, renaming, moving, again the user view does not changes, the application, the system does not changes. There's a change in the logical structure of the table, again the user view should not change. Okay, even if you split two tables, when I look at that table, I should basically look at one single table only, which internally has been joined to provide me that view. And this is, like I said, one of the most difficult rules to satisfy. Okay, so now what we'll do is we will move on to rule number 10. Okay, and the rule number 10 talks about integrity independence. Okay, so integrity is something also which we are going to cover in the next part. Now the database should be able, the rule says that the database should be able to enforce its own integrity rather than using other programs. Okay, for example, keys and check constraints, trigger, etc. should be stored in data dictionary. This should also make RDBMS independent of front end. So there are a few integrity constraints, okay, that you will read about in the future classes as well, which talks about, you know, what kind of data, what are the domain constraints, right, what are the entity constraints, and there are a few constraints or rules that you have to enforce in your databases. So the rule number 10 says that those rules should be enforced by the database itself, okay, by RDBMS itself, instead of using other third-party programs which are enforcing these integrity rules on you. Okay, there are key constraints like I talked about, there are entity constraints, attribute constraints, domain constraints, right? All these things should be constraints, should be stored in your data dictionary, okay, so that you're not dependent on actually some other program or some outside dependency is not there to actually enforce and implement all of these constraints. So it should be integrity independence. Okay, all the integrity that you actually require in your database should be enforced by RDBMS itself instead of being dependent on outside programs. Then we talk about rule number 11. Now rule number 11 says distribution independence. It says that a database should work properly regardless of its distribution across a network. Even if a database is geographically distributed with data stored in pieces, the end user should get the impression that it is stored in the same place. This lays the foundation of distributed databases. Okay, so I think the definition itself is pretty much very clear, but I'll give you like a more realistic and holistic view about it. So what happens is, whenever you are dealing with databases now, sometimes the databases are very big, okay, and sometimes the use case and the usage of databases is also distributed over the entire network and over the entire world. Okay, so in those situations the concept of distributed databases comes into picture. That means you are not storing the entire database into one place, rather the database is stored into multiple places across the network. Some part of the database might be stored somewhere else in the world, some part of the database might be stored somewhere else, as it says the word here, geographically distributed. Okay, the data is stored into bits and pieces all over the geographical network. Okay, but when I try to access that data, I should not feel that the data that I am looking at is geographically distributed. I should get the idea, or I should feel that the data is actually coming from one place itself and it is not geographically distributed. So whatever distribution of data we are following or applying, right, for the database, the user should be independent of that data distribution. Okay, the user should not get an impression at all that the data that you're coming, let's say this database is not geographically distributed or this database is geographically distributed. The user should not be able to make that call, the user should not be able to make that distribution. Okay, and that is what distributed databases are. There is one known as centrally located database, where actually the entire database is stored at one place. Okay, usually those databases are small as well, but many times the database is very big, the database is very huge, and the use case for databases all over the world. So you try to make it geographically distributed, right? You try to keep secondary databases, you try to keep backups, you try to keep it distributed. Okay, again, because it's a requirement, but to the user it should not look like that any kind of distribution is happening. And the last rule over here, which is rule number 13 but known as rule number 12, is that non-subversion rule, which basically talks about the fact that if low level access, okay, is allowed to a system, okay, it should not be able to subvert or bypass integrity rules to change the data. Okay, this can be achieved by some sort of locking or encryption. It's not looking, it's locking. Okay, so what says, let's say you have some kind of access allowed where you have the low level access, where you are actually at the very root level, okay, and you're actually able to be at the, at the very lowest level possible to get access to the RDBMS system. Now, even if you do have the access to that, you should not be able to bypass or ignore the integrity rules, right? I told you there are a lot of integrity constraints. In no situation, even if you have the lowest level of access possible, you should not be never allowed to bypass the integrity rules, and you should not be able to change data that actually bypasses those rules. Okay, and how do you achieve this, right? How do you make sure that rule number 12 is achieved? By some sort of encryption, by some sort of locking that you've actually introduced in the data, right? It's an encrypted data, so the user sees only XXXXX, where actually internally you are storing the real data. So that's called encryption. You're not really allowing the user to see the real data, and the advantage of that is, since the user does not see the data, the user does not know what the actual data is, they cannot really make the call whether to change the data or not, and hence the integrity constraints are being followed. Okay, so that was the rule. Non-subversion rule is like non-bypassable. No matter what kind of access you have to the data, you should not be able to bypass any of the rules. Okay, so that's what pretty much the overall concept behind non-subversion is. And this concludes all the 13 rules which are defined by EF code. Okay, so let's quickly take a look at again and the last 7 rules that we discuss. Rule number 6 is view updation rules. Okay, that means any view which look like it's theoretically possible to update that view, it should actually be updatable by the system using the query language as well. Now we talk about rule number 7. Rule number 7 says that at any level, okay, at any level of the data, at any level of the relations that you're dealing with, all the operations, insertion, deletion, updation, fetch, all of it should be possible to do. Okay, it should not be like at any level this kind of operations are not allowed, and if it is not possible, then it's a direct violation of the rule. Even the operations where, let's say, some set of records are in some place and other set of records in another place, if I want to do union, intersection, minus, plus anything that I want to do, all of it should also be supported. They are known as set operations. Why? Because you perform that on 2 different or 3 different sets of data or multiple sets of data, not just like a single record. Next is physical data independence. No matter how you are storing the data on the disk, right? No matter how you are storing the data on the server, the user should not be affected by that. If, let's say, if some file is storing the data, the file is renamed, okay? The file is moved from one place to another place in your disk. As a user, as an application, we should be independent of that knowledge, okay? No matter how you store the data, no matter how you change the physical, like physical is like I told you, right? Hardware. No matter how that is being perceived, the user should not affect the application. The application should not be get affected by this. Ninth is logical data independence. Similarly to physical independence, let's say you do some change in the structure, the logical structure of the data, okay? Still, the view of the database or to the user should not get changed. If you split the table into 2 tables to store them in a more logical way, right? Even as a user, if I will look at it, I will look at the join of 2 tables only. I will look at that original single table itself, even though you might have logically splitted it into 2 tables. So even if you do a logical splitting, a logical change in the or updation in the structure of the database, the table of the database, as a user, for me, the view of the data still remains the same. And this is actually one of the most difficult rules to satisfy, because you have to maintain constant and you have to generate constant views to make sure that none of the users actually get affected. Then we talked about integrity independence, right? So integrity are a few set of rules which are enforced. For example, key rules that like the key values should never be null, the key values should always be unique, right? Or some kind of domain constraint. That means in an age, you should only store age, right? In an address, you should only store address. So these are a few integrity constraints which are enforced on the databases. And these should be enforced by the database itself rather than using outside programs which enforce these rules, okay? That is not at all allowed. These rules, these constraints should be stored in the data dictionary, and your RDBMS should be independent of the front end, should be independent of the other programs that implement integrity. Your database itself should implement or enforce integrity rules. So you are independent. Rule number 11 is distribution independent. That means no matter how your database is geographically distributed, no matter in what all areas is your database geographically distributed and what all pieces are you stored in certain location, as a user, I should never be able to take the call whether a particular database is centrally located or distributed, okay? As a user, I should get the impression that everything is stored at one place only and I'm getting every information from a single place itself, okay? I should not get different views. And this actually is what distributed databases is as well. And the last rule over here is the non-subversion rule, which says that even if someone has the lowest level of access to your RDBMS system also, still they are not allowed to bypass the integrity rules, because integrity rules actually make sure that your databases are consistent. There is no loss of information as well. Okay, so no matter what level of access is allowed to a system, right, nobody should be able to bypass those integrity rules. And this can actually be achieved by, you can either perform or add some kind of locks to the databases, you can do the encryption of the data, anything that you want, but you have to make sure that all these rules are followed. Okay, so that's what pretty much in a wholesome picture all the 13 rules are. If you have not watched the previous video, make sure you watch that video first, because it talks about the first 6 rules, and there here in this video we talk about the next 7 rules. And this concludes our discussion for the EF code rules that are there. They are very important. Like I said, relational databases is something that we very extensively use. So again, it's really important that we have a good knowledge and a good idea about how these rules work as well, right? Again, we do not follow all of them, but it's good to know how an ideal database should really look like. So even if we're not following all the rules right now, we should ideally tread in a direction that we actually make sure that in future we design better databases, right? We move towards from a DBMS to RDBMS kind of a system where everything is more easy, right, to use, and a more consistent information is provided and in an optimized manner. Okay. So I understand this is a theoretical topic, but again, it's very, very important that you devise a good, way to learn this, right? All of the rules are very important, right? You should know and understand all the rules by heart. What I recommend usually to students is that the name of the rules should actually become the backbone for understanding the idea what the rule kind of persists. Okay, so make sure the names are very much clear to you and you understand that by heart, and trust me, with that you will actually understand what the rule is trying to say as well. Okay, so thank you so much for attending this video. I hope you were able to understand all the rules. Next we are going to move ahead and talk about the basic RDBMS concepts, which are small bits and pieces that you should know, that we are going to use these terminologies again and again for your better understanding. Okay, so let's quickly move on to the next section as well. Thank you so much for attending this, and I will meet you in the next one.